The next reaction is Beeckman's rearrangement. It is Beckman. Okay, Beeckman rearrangement. It was named after a German Ernst Otto Beeckman, who discovered this reaction. So what is this reaction basically? What is Beeckman's reaction? Okay, what is Beeckman's? It's an acid catalyst. So an acid is used as a catalyst of conversion of a ketoxide. Conversion of a ketoxide. Ketoxide means you treat ketones with your oxime, with your hydroxylamine. You get a ketoxide. Which gets converted to an N-substituted amide. So it's a conversion of an oxime to an amide. Okay, it's known as Beeckman's rearrangement. So what is Beeckman's rearrangement? You take an oxime, you take it in an acid, PCl5 or this thing. It undergoes rearrangement. It undergoes rearrangement to give you an substituted amide. You get a N substituted amide. Means one of the alkyl or aryl, any group from your ketoxime gets migrated to your nitrogen. So that's your conversion of your oxime into amide. Okay, conversion of oxime into amide. So now let's go for the next. So what? So what happens in this thing? So basically it is protonation of your OH of your oxime, removal of water. If you see water is lost, you get a nitrogen ion. Okay, so it forms a carbocation. This carbocation gets attacked by your water again, and it undergoes tautomerism to give your. So in this case, so when there is a loss of water, there is a loss of water, there is an internal migration. There is an 1-2 migration. The group which is on the one of the alkyl or aryl group. Okay, one of the alkyl or aryl group which is present in your oxime, as your water goes off, gets shifted to your nitrogen. Gets shifted to your nitrogen, and you get a nitrinium. And this gets this gets a nitrinium ion gets attacked by your water. There is a loss of proton. Okay, that's why it is a regeneration. And the last step is your ketoenol tautomerism. You get your corresponding amide. So this is the basic mechanism of your this. And there is, if you see in this particular reaction, the most important thing is you see how the migration takes place. Now you have studied the stereochemistry, you have studied the naming. So when OH and the group, it is anti to each other, it is trans to each other. The group that is migrating in this particular reaction is trans to your OH. Okay, so when the water is lost, the group which is trans to your OH migrates. There is a 1-2 migration of a trans, no cis. The group which is on the same side of your OH does not migrate. So only the group which is trans. So this was studied by using very isotopic. You take an isotopic group and we try to find out the amide. So this was understood. So it was a transmigration that takes place. Now let's go step by step. So the first step, as I said, it is protonation. That is, you get your intermediate one. Your OH on your oxime gets protonated, which is a good leaving group. So loss of leaving group, that is water, generates an electron deficient species, which is accompanied by. So when there is a loss of water, there is an electron deficient. Your nitrogen gets electron deficient. So to fulfill the electron deficiency, one of the group which is trans, okay, one of the group which is trans to your migrating group, okay, that group gets transferred to your nitrogen, okay, this leading to a nitrinium or immunocarbocation. Immuno means double bond. And since there is a positive charge on the carbon, it is known as immuno or a nitrinium ion, or it can be also called as immunocarbocation. It's a immuno. So this is the second step. That so there is a transmigration of the group, which is trans to your leaving group, migrates, and it gets shifted to your nitrogen. That is your second step. That is your second step of the reaction. Now let's go for the third. So what happens? Now this nitrogen ion is formed. That intermediate gets attacked by your water molecule. Okay, there is a loss of proton to give you an O imine. OH in imine intermediate. In imine all. So then it undergoes a tautomerism or a resonance. It undergoes tautomerism. Okay, it undergoes tautomerism. Okay, and you get your corresponding amide. You get your corresponding amide. You get your corresponding, the hydrogen from your O gets shifted to your NH. Okay, so this is what happens in this reaction. Okay, this is what happens in this reaction. Last step is your tautomerism. So this was case of your normal oxide. So if you got a cyclic oxide, that is a cyclohexane, you treat it with an hydroxylamine hydro, you get your corresponding your oxide. Now this oxime also, when you treat it, it undergoes a Beeckman's reaction and you get a caprolactam. That is, ring expansion takes place and you get a cyclic amide. You get a cyclic amide. So it's stereochemistry. Let us see how the stereochemistry of this thing. So there is an intramolecular rearrangement. The rearrangement takes place within the molecule. So which group migrates? If you see in this reaction, you take mixture of two and they try to find out the product. So which product was formed? Okay, you take a ketoxime, dimethyl ketoxime and phenylmethyl ketoxime. And when they analyzed it, they found that you get a phenyl substituted, amide and a methyl substituted. So that shows that there is a transmigration. The migration is always trans. The reaction is stereo specific, only trans group migrate, and the reaction occurs in a polar solvent only. The reaction occurs in a, because it stabilizes your leaving group. And your anion that is. Okay. The stereochemistry, as we said, it is a stereospecific reaction. The group which is always anti to your OH migrates, or on the opposite side of OH gets migrated and rearranged. So it's a highly stereospecific reaction, where only stereospecific means only one product is formed. Only anti-migration takes, no cis migration takes place. Only transmigration takes place. Okay, so this is your example. Okay, now its application. It is used in the preparation of various amides. From ketoxams you can prepare various as substituted amides. Okay, and so this is your first thing, preparation of various anides. It is used for preparation of your isoquinoline molecule. It undergoes rearrangement and you get an isoquinoline. So it is also used for the preparation of your isoquinoline molecule. This is one of the methods for preparation of your isoquinoline. It is cinnamaldehyde oxime. So what happens? The group which is para to this thing migrates. The group which is para gets migrated and you get your isoquinoline molecule. Next is configuration of it is assigned. So which type? As we said, only your transmigration takes place. Okay, which can be further converted into your amides and amine. As I said, it can be also used for the preparation of your caprolactam. Okay, it can be used for the preparation of your, it is NH, not OH, it is NH. It is used for the preparation of caprolactam, okay, which is used for the synthesis of nylon 6 polymer It's a textile polymer. It is used for the preparation of your, so ring opening takes place and you get your polymer. So that was your Beeckman's theorem. Now Claisen-Schmidt condensation. You might have studied this Claisen-Schmidt condensation in your previous semester. That is preparation of dibenzyl acetone. Dibenzyl acetone. So what type of reaction it is? It's a reaction between a ketone and a carbonyl compound lacking alpha hydrogen. Lacking alpha, so aromatic aldehydes. Okay. So it's a crossed aldol condensation. So it's a reaction between a ketone and a carbonyl compound lacking alpha hydrogen atom. It's an example of crossed aldol condensation, and this type of reaction is known as Claisen-Schmidt reaction. Your common example is dibenzyl acetone, dibenzylidine acetone, which you have prepared in your semester. So what is the reaction that occurs? You take benzaldehyde, you treat it with acetone. The first product what you get is phenyl 3-en-butane. Okay, that is your first one. And further, if you take excess, so it gets your second molecule of your benzaldehyde also gets attacked because there is one more CH2 group. So that can also, so you get your dibenzylidine acetone. Next is what? You take your benzophenone and you treat it with your benzaldehyde. You get 1,3-diphenyl propene 1-one. That is benzyl acetophenone. So this can be used for preparation of this reagent, which is an important intermediate in various synthetic processes. Okay. So now let's go for the reaction mechanism. So what do you do? What was the first step? The first step is your base is there. You got an acetone moiety. So the base abstracts your alpha hydrogen atom from your acetone. So to generate a nucleophile, it undergoes tautomerism. Okay. This nucleophile then attacks on the carbonyl carbon of your aldehyde, aromatic aldehyde. Okay. So you get your OH minus. Okay. Again, the second molecule. Okay. So what is the next thing? Again, the third step is what? This intermediate that is formed. Okay. You get your OH, gets water protonated by your water. That is your first step. So this base that is present will remove your proton, which is alpha to your carbonyl carbon, and there is a loss of water, and you get your dibenzylidine. So you get your benzylidine acid. So that is your first step. This reaction can be further continued where the next methylene, active methylene group can be abstracted to generate a carbanion, which will attack on the second molecule of benzaldehyde, and you get your dibenzylidine group. You get your dibenzylidine. So it is an dehydration. First is your attack, OH, water is formed. Then your base abstracts a proton and you get your corresponding compound. Okay. The bases used mostly are potassium tertiary butadiene, sodium hydroxide, sodium hydride, which is used. So it can also undergo acid catalyzed enol mechanism also. This reaction can take place in presence of your acid. Now let's go step by step what we did. What is the first step? As I said, base abstracts your proton, you get your enolate anion. It undergoes tautomerism. This enolate ion attacks on your carbonyl carbon of your aldehyde, benzaldehyde. You get an alkoxide anion. You get an alkoxide anion. You get an alkoxide anion. So what is the next step? This alkoxide ion gets protonated by water. You get your corresponding OH. Okay. Now what is the next step? The OH, the base which is present in the reaction, will abstract your active methylene, H from your active methylene. In doing so, there is a loss of water and you get a 4-phenyl 3-butene 2-one. So that is your first product of the reaction. Okay, by the dehydration. That is the first product of the reaction. Okay. So this furthermore the reaction can take place. You know, the active methylene group again gets converted into a nuclear and you get the second molecule gets added. So the reaction can be. So what is the application of this thing? You know, grenalin. So it is used for the in preparation of your vitamin A. It is used in the preparation of vitamin A synthesis. That is used in the preparation of your granulin. You treat it with acetaldehyde. Sorry, acetone. You get your pseudodino. Okay, where there is an introduction of a double bond. So this chain will be continuing and you get your side chain of your vitamin E, vitamin A. Okay, this is a very important method for preparation of your vitamin A, and it is also used to preparation of your side chain of your benzenes with the double bond. So this Claisen-Schmidt reaction is used in such reaction. Okay, dibenzyl acetone, which is used. So this is acetophenone, that also was benzaldehyde with acetophenone. You get benzalidine acetophenone, that is a chalcone. Even this chalcone is also used for preparation of various aromatic compounds like your substituted imidazole. You can be prepared. Substituted imidazole can be prepared by this method. Okay, so these are the uses of your Claisen-Schmidt condensation reaction. These are the uses of Claisen-Schmidt condensation reaction. Now, the last reaction in your reagent topic is Schmidt reaction. So, what is this Schmidt reaction? So, it involves the reaction between carboxylic acid. It involves the reaction between carboxylic acid and hydroxylic acid in presence of sulfuric acid to form an amine. So what is this reaction? It converts an carboxylic acid to an amine by reaction with hydroxylic acid in presence of your sulfuric acid. Your catalyst is an sulfuric acid, protic or a Lewis acid can be used as an catalyst. Okay, now let's see the reaction. So what happens in acidic medium? Your carboxylic acid reacts with your hydroxylic acid, that is HN3. Hydroxylic acid is nothing but HN3, that is hydroxylic acid. In presence of your acid, it will give you a corresponding amine. It will give you a corresponding amine. So this azide, what are azides? N3, CON3 are nucleophiles at the terminal nitrogen atom. Okay, this hydro and may add suitably activated nucleophile in the presence of. So what is this nucleophile? The nucleophile can be generated. The water is lost. It generates an electrophile in presence of an activated nucleophile. Your carbonyl group can act as a electrophile. So that electrophile is generated. This hydroxylic acid then will attack on your activated carbonyl group, that is your electrophile. So this is your basic mechanism of action. Now let's see the mechanism. Let's see the mechanism of action. Let's see the mechanism. So what is the first step? What is the first step? That is the protonation of your acids. Once the acid gets protonated, there is a loss of water. This loss of water leads to the formation of your asylum ion. That is, carbonyl group gets positively charged. It acts as an electrophile. Now this hydroxylic acid, if you see the hydroxylic acid, okay, it has 3 nitrogen. So it undergoes, one of the nitrogen has negative charge. It gives us the electron to the first nitrogen will give the electron, and this will then attack on the carbonyl carbon. So when this attacks, you get this particular intermediate number 2, that is azido keto intermediate, that is known as azido. Why it is called azido group? Because it has a nitrogen, 3 nitrogen group with a ketonic group, carbonyl group. That's why it is known as azido keto group. N3C double bond. So what is the next step? The next step is what? There is an alkyl group migrates. In migrate, there is a loss of nitrogen. In doing so, when the nitrogen is lost, your R group migrates to your nitrogen. In doing so, the R groups gets migrated to your nitrogen, thus leading to formation of an isocyanate ion. This leads to the formation of your isocyanate ion. Okay. Now this isocyanate ion gets attacked by your water. So gets attacked by your water. Okay, to form a carbamate 4. What is carbamate? NHC double bond OOH. This forms a carbamate. And this carbamate gets deprotonated with the loss of carbon dioxide. So it gets deprotonated and there is a loss of carbon dioxide and you get your amine. So this is the mechanism. So what is the first step? Protonation, generation. This is loss of water. Generation of a electrophilic asylum ion. This gets attacked by your nitrogens of your hydroxylic acid. this gets attacked by your nitrogen of your hydrozoic acid. Okay. Followed, this leads to the formation of keto. It leads to the formation of your acido-keto intermediate. That is your. Now, next step is loss of nitrogen. N2. When nitrogen is lost, it leads to a formation of your protonated isocyanate. You get ion. You get a protonated isocyanate. This protonated isocyanate ion. So what happens? O attacks, the bond comes to your nitrogen. So one of the H gets the water gives one of the H to your nitrogen, and OH attacks on the carbonyl carbon. So to give you an carbamate intermediate, protonated, you get a carbamate intermediate. Now this carbamate intermediate 4 undergoes deprotonation with the loss of carbon dioxide to give your corresponding amine. So this is the mechanism of Schmidt reaction. Schmidt-Curtius reaction. Okay, it's known as Schmidt-Curtius reaction. Very important from your examination point of view. They will ask the condition and the C. This Schmidt condition reaction can also be used for the converting your ketones to your aniline. Okay, and double bonds, alkenes to your substituted imines, and your acid to your. So these are some of the applications of your Schmidt reaction. These are some of the applications of your Schmidt